Hi, welcome to CAD-107. I'm Joe Cerrone.
And I'm Al Rosen.
I'm going to go over the Chapter 2 3D printers and printable materials with Al today. And we're just going to do a quick summary on the chapter. This chapter covers 3D printers and the materials that they run on. And so as we start to look at 3D printers and filament, we'll talk about that in this chapter. The first thing that the author talks about is that the 3D printing world uses metric measurements. And so you're going to want to get more comfortable with metric measurements. You're also going to want to use metric title blocks because as we import those CAD models into our slicing program, we may have to adjust or scale them from inches to millimeters. And so this is a very common thing. So when we bring something into the slicing program, if I'm able to go here and say File Open, and I go into my 3D printing, here's a tag that we created, and I open it, it's tiny. And so that's because this was done in inches. And so what I'll do is I'll scale that by 2540. And so that's just an example of how the metric world kind of ties into our 3D printing. Back to our lecture. So as we start to work with our 3D printing world, we're talking mostly in millimeters, or we're going to be converting imperial units over to metric units. And the same thing as far as the filament. When we look at the filament, we can use a number of different filaments. For the most part, we're going to be using FDM technology or fused deposit modeling, sort of like a big glue gun, to put it simply. When we look at the type of 3D printers that we're talking about, there are several different architectures in these printers. And they use a Cartesian or they use sort of a delta bot type of a configuration. My personal experience is that the Cartesian printers are a little bit more reliable and easier to set up than the delta bots. Here's your Cartesian coordinate system with the x-axis going horizontal, your y-axis going this way, and your z-axis going vertically. The delta printers look like this, and these motors run up and down and then control the print head. And so we have one of these CME CNC printers over at the Skokie lab. They do have a very large build volume, so they are pretty cool, and they're not super expensive either. You can get into these for under $1,000, but I find they're a little bit trickier. Here's a really large delta bot, and you can see they're printing sort of a rocket, and it looks like it's a good 5 or 6 feet tall. So as we look at these printers, we can talk about the parts of the printers. Stepper motors are used to control these axes or control the print heads. They don't cost too much compared to servo motors, which are a closed loop feedback system. So here's an example of a stepper motor, and it's got this drive belt on it. Control of the 3D printers is often done by these Arduino microcontrollers. We often have to upgrade the firmware on those. And the author is sort of an MIT graduate, and she likes to go into all the techie stuff as far as the chips and things like that. But essentially, it doesn't take a lot of horsepower to run these. As we look at the build platform or the pallet is what the material is printed on. And so it's sort of a print bed. And so if we were to look at a Google, if we say Dremel, and if we look at the Dremel 3D printers, what we're talking about in the palette is this blue area right here. They come out when we work with them. You can actually go through and we purchase multiple pallets so that we can just swap them out and put in a new one.
Oh, you can't see it. You have the drawing up there?
Okay, so let's see. Let's do a new share. Thanks, Al. I need that. So when we look at the pallet, what we're talking about is this area right here. And so these pop out of the machine and are used to hold the part on the pallet as it's printing. And remember, the print times are 3 hours, 4 hours, 10 hours. So it's very important that it stays securely attached to the printer pallet. Can you see this screen now, Al?
Yes.
Great. When we're talking about the extruder, what we're talking about is the nozzle that the material comes out of. And it's a heated nozzle with a sensor called a thermistor. And it basically controls the temperature. And so the temperatures are very precise, and as are the nozzle diameters. And so as the hot end heats up, the material is pulled through the nozzle. And this is an example of a nozzle. The nozzle is right here. And so when we start to work with the printers, we'll put the filament in and it will extrude from the nozzle as we're getting things set up. And so the filament needs to be pulled from the spool into the printer, usually with a gear-driven motor. And so if we look at our Bosch Dremel printers, we actually have a coil that is input right here and then goes into the printer through the top into the print head. Here's another example of an extruder gear in a printer with a Bowden tube. It's just a tube. It's just a plastic tube that guides the filament into the print head or into the nozzle. And there's typically a couple of gears that will pull it into the area for it to be heated and then extruded. So as we start to go through the nuts and bolts of how these 3D printers work, we're talking about the nozzle and the filament and how that filament gets pulled into the 3D printer. Some other aspects about this technology is that we are using CAD quite extensively. And so as we work with these printers, it's a good idea to have a printer that doesn't need to be attached to a computer because you have to tie up the computer time. So most of them have an SD card or you can use a wireless connection. And so we'll often go through and use the USB connection. It's just a little USB port right here. We can save our files as a G-code file, put it into the USB port, and then we can go and configure the file to be printed directly on the machine. The book also talks about the first layer has to stick well to the platform. So as we start to work with some of the technologies and what goes wrong and what doesn't go wrong, it talks a little bit about how the nozzle, how the filament will be retracted from the nozzle, and when it goes through and stops printing and when it starts printing. Sometimes they have what's called a purge tower, but you can get some really goofy looking prints with poor retraction settings if they're not set properly. The good thing about the printers that we're using is that they have sensors in the machine that sense the material and they set it up according to the printer properties. And so we can actually set up these printers that will detect the material and they'll set up the extrusion and the temperature with an RFID chip that's contained within the filament spool. It's not uncommon to have a bird's nest. We oftentimes now have cameras in the 3D printers. And so you can remotely monitor your printer and then pause it or stop it if it starts to do this. Now, what is it doing here? It's basically printing in the air just this line of plastic. And so if it doesn't stick layer by layer, you you can come into this sort of a failed print. And it happens to everybody as you get more and more experience with these 3D printers. So as we look at it, some of the machines will use support material, and we'll also talk about overhangs. How much of an overhang, or how much can you print over nothing? Okay, and so typically it's a 45-degree, and as we go through and we start working with our printers, we'll talk about that. And so here's a print photo of a cube with support material. That's what this stuff is right down here at the bottom. And the support material is easy to separate from the model. It actually kind of just chips right off or peels right off. And so when we print something that has an overhang or needs support, we'll enable the support material. Some other prints showing close-ups of the layers. You can see this is a multicolored material, and then you can see each of the layers as it's built up. There's a number of filament choices, and filaments are really the fun part of working with 3D printers. We can work with different colors, we can work with different materials. We have materials that look like wood, we have materials that look like plastic. So for example, if we go on to Amazon, and we go into 3D printer material, notice that you need to dial in the filament diameter. And so we're using this 1.75 millimeter diameter on these Dremel 3D printers. Some of the other printers will use a different diameter. So you need to ensure that you're getting the correct filament. But as we go through and we look at printer filaments, there's some really cool stuff out there. And so here's an example of some of these. You've got your typical PLA filaments, polylactic acid, 1.75 millimeter, ABS. This is PLA, I'm sorry. Other ones will be ABS, or they'll be semi-transparent type filaments. The silk comes out really nice. It sort of has sort of a shine to it that makes it appear like metal. And the costs are really relatively reasonable. Here's another silk that looks sort of like metal. You can also get materials that glow in the dark. So there's a lot of really interesting aspects. The wood filaments are really kind of fun, and they actually smell like wood and look like wood. And you can actually print things like a box, and then you can actually post-produce them or finish them and stain them. So choices of filaments are varied, and it's really very cool. Get yourself a pair of digital calipers. If I go in here and I look at my orders, I won't do that. Who knows what we'll see. But if I go into a caliper, I picked up one of these calipers for $9.99 this week, and it's great. I can use either inches or millimeters. And if you're going to do something where you're replacing a part from your kitchen stove, or I'm working on some plant stands for around my house, and I'm used to using inch measurements, I just click on the button, the blue button, and switch it over to millimeters, and then I can get some real world sizes. So it's a great idea to order one of these digital calipers as you get better with your design experience. Okay, and here's an example. It's also a good way to check to see if your filament is the right size. So again, filaments come in a broad range. The filaments will be labeled as far as to how they're set up. PLA, polylactic acid, is the most common. It's a plant-based biodegradable material. Doesn't have any harmful fumes. So that's our choice. But one problem with PLA is its low temperature melting point. And so what can happen, just like people who remember vinyl records, if you leave it in your car on a hot day, it'll warp. And so you have to be careful about where you're placing these 3D printed projects. So for example, if we're making something that goes outside, like a wind powered generator, and the heat gets over 80 degrees, 90 degrees, that part will probably warp if it's made out of PLA. So you're going to want to look at different materials for different applications. PLA is great for things like vases, indoor things, signs. PET is a material that we use often for things like lampshades and for things that we'll use for lighting because it's semi-transparent. And so when we go through and we use the PET, we'll do things like make shades, and they are really kind of neat. We've got a couple of projects in our book for that. ABS is what Lego bricks are made out of, and it has a higher melting point. So ABS is tougher, it's better for more heavy duty type applications. And our industrial printers, like our Stratus Dimension, will use ABS. Nylon is another material. It can be a little bit challenging, but it also has a high temperature melting point. And so it has some uses that are better. Some of the problems with it are getting it to stick to the platform. So they often have these things like Gargolite. And if we go into here and we look at Gargolite, it's basically something that holds the material to the pallet. And they do sell this for the Dremel 3D printers. And so you can actually just ensure that you have a good print. But for the most part, we're doing pretty well with the way it's set up, just using Elmer's, well, not Elmer's, but there's a specific glue stick. We've been using the Scott brand 3D, the Scott brand glue sticks. But the glue sticks are important as far as we go through and set up the adhesion. Some of the challenging filaments, those would be the ones that look like metal, or they look like wood, or they have other aspects to them. We also do some work with dissolvable support materials. In order to use dissolvable support materials, you have to have a dual head printer. And so by having a dual head printer, you can print this dissolvable support material, and then we can put that into a immersion tank, which essentially dissolves the dissolvable support. And so when we use some of the Stratus Dimension 3D printers, we take the parts out of the printer and then we'll put it into a tank, and that tank will have either water or a mild acid in it that will then dissolve the support. And oftentimes they have a tank that that dissolvable support material is placed in. So as we look at using support materials in multi-extruders, there are different ways to achieve that. And so there are some aftermarket upgrades, build tack, again, how to stick to the pallet. And then some of these other companies like Mark Forge can print carbon fiber, and so they can print some extremely strong parts. 3D printing pens are really just kind of for repair. So you can get a 3D printing pen and repair some of your prints by putting down some more material. But they're difficult to work with if you're just freehanding it. It kind of takes a very steady hand to get them to look properly set up. Other printers like SLA, DLP, and LCD printers cure a resin, and they're very precise. They print really good projects. So if we look at something like the Form 2 printer, we're looking at a printer that will print with these resins and a laser, and they print very, very fine prints. So here's another example of an SLA resin printer. And at this point, we're thinking about getting into this on a limited scale, but for the most part, we're just really cranking things out with the FDM type printers. And then our next phase will be to go into some of these SLA printers. But there are some things as far as to working with these that material costs, fumes, and things like that that we need to keep an eye on. But they're very precise and they have a high resolution, and so they're very good. Post-processing involves washing or cleaning up your print. And so it's a good idea to have a pair of gloves, safety glasses, and some tools like files and clippers to be able to get the part ready for prototyping. There are some other interesting things you can get into as far as to working with these 3D printers and the resins. A lot of jewelry makers will use 3D printers to create molds that they can then cast their jewelry in. Other technologies, food printing is kind of neat. I'm not really jumping into printing food because people are so picky about how things taste. So you can print something that might look really cool, but I'm not sure if we're ready for those kind of things yet. I have heard people have quite a bit of fun with getting wedding cakes with 3D printed scans of the bride and groom on them. As we look at other things like selective laser sintering, these are very expensive. These are kind of the older school type printers that are used by industry. Biojet printing, being able to print cells, is a new technology, another area to look into. But for the most part, we're going through and using these FDM printers, and we'll be going through and making mechanical parts and things like that. As we look at the end of the chapter, what we want to do is to be able to understand some of these objectives, like what are the merits of 3D printers that use filament versus liquid resin. We want to look at commonly used filament materials. And so as we go through the course, we're going to start with PLA. Components of these materials like temperature sensitivity is very important. All right, so this ends our quick recap of chapter 2. And our next video will go through our parts and how to create them. And so we'll be looking at a couple of the parts that we created. This was our lab 2, our video conference sign. And we'll go into how to slice these and how to start printing in our next week's class. Al, anything we need to add?
No, but if they are ready to hand in work, please do so and put it into an assignment box, Dropbox area, so we can grade them and turn them back into them. That's really also very important, please. Also, if you have a question for Joe and myself and you want to email it to us, please do so, but also indicate that you're in our CAD-107 class. Thank you very much.
Alrighty, so I'm going to end this video and we'll post it and we'll hold our normal Zoom meeting to go through any other questions and comments.